Welcome to our class. Today we are going to discuss about the reversible and irreversible process. From our previous lecture, you might have a clear idea about what is a process. In case of thermodynamics, process is the way in which one thermodynamic system changes from one state to another state. And you know that the process can be classified into different classes from your viewpoint. That means from a different angle of view, you can classify the process into different classes. And in our earlier classes, we discussed about 5 types of processes, namely isothermal process, isobaric process, isochoric process, cyclic process, etc., etc. Today, we are going to discuss about reversible and irreversible process. Now let's move on. What is a reversible process? In case of thermodynamics, reversible process is one that takes place infinitesimally slowly, and its direction at any point can be reversed by an infinitesimal change in the state of the system. So what does it mean by reversible process? To understand what is a reversible process, now let's look at the figure. In the left side hand, you can see this is a cylinder, this is a cylinder which contains gas, and the cylinder is already fitted with a piston. This is the piston. Now, if it is a reversible process, then whenever the cylinder moves, its movement can be reversed. It can be reversed at any point. For example, this might be the initial position of the piston, and the piston is moving from this position to the final position through this course, through this path. Now, you can reverse the motion or direction of movement of the piston from any point, starting from this point to the final point. Suppose you are trying to reverse, or you want to reverse the movement of piston from upward to the downward, and the point in which you want to reverse the position or movement of the piston is just located in this area. So you can easily, if it is a reversible process, so you can easily reverse the movement of the piston from this point to the initial position, and the work done during this movement will be totally reversed. Suppose the gas is expanded during the movement of piston from this initial point to this intermediate point. Now, if you reverse the movement, then what will happen? The piston will move from this intermediate position to the initial position. So if the gas has expanded in the earlier action, now it will be compressed by your reverse action. If the gas has done some work during the expansion, now the work will be reversed during its compression. That is why reversible process will produce you or give you much more efficient working capacity than the irreversible process. So now come to the next point, which is called the irreversible process. What is irreversible process? With thermodynamics, whenever a process goes from the initial state to the final state in a single step and cannot be carried out in the reverse order, is said to be a irreversible process. Said to be an irreversible process. Okay, that means in case of irreversible process, there is no chance or scope for reversing the process. For example, in this case, this is a cylinder. The right hand side figure indicates a cylinder which contains gas, and the cylinder is fitted with the piston. Now, if the piston moves from the initial position to the final position in a single step or in a single operation, and if it is not possible to reverse the movement of the cylinder at any point, then it will be regarded as a irreversible process, and there will be no intermediate position. But in case of reversible process, there was an intermediate position. Also, there are some many differences between the reversible process and the irreversible process. One of them I have already mentioned, that in case of reversible process, the working efficiency or the amount of work obtained is much more greater. But in case of irreversible process, since it cannot be reversed, or the operation is completed in a single step, that is why that is not possible to reverse the work or reproduce the work. Let me explain this with the help of this diagram. Suppose the piston is in the initial position. In case of reversible process, it will move into the final position in some infinitesimally small steps, and at any step you can reverse the position. That means, suppose the piston is now in this intermediate position. Now you can easily reverse the movement of the piston, and the piston will come back into the initial position again. After coming to the initial position, you can now reverse the direction or movement of the initial piston. That means you can now again move the piston from this position to this initial intermediate position. That means the action can be repeated for several times. The action can be repeated for several times. But in case of irreversible process, the action cannot be repeated for several times. That is why in case of spring, you can you can stress the spring, and whenever you drops it, then it regains it or attains its original state. But in case of plastic or etc., it is not possible to gain the initial state after stretching it from its original state. That means if it is a rubber, then you can elongate the rubber, and after leaving it, it will shrink again. But in case of a normal metal or any other type of strip, the elongation will not take place. But if you insist to elongate it, it will elongate, but it will not reverse in its initial state. That is why in case of reversible process, always it is efficient, and it will give you more work, and it will give you the chance or opportunity to reuse the material again and again. But irreversible process will not give you such opportunity. Like that, there are lots of differences between the reversible and irreversible process. Now let's look at some of the differences between the reversible and irreversible process. From the definition, we can state that we know that the reversible process takes place in infinite number of infinitesimally small steps. But the reversible process takes place in a finite time or finite time. Why? Because there is no infinitesimally small step. That is why the occurs in a single step, and the duration of action is definite. So the time required for accomplishing a irreversible process is measurable, and it has a definite value. But in case of reversible process, since the operation occurs in small steps, infinitesimally small steps, that is why the time required for accomplishment of the reversible process is infinite or infinite. That is why it is not possible for us to calculate or measure the actual time that would be required for accomplishing or ending a reversible process. Number 2, in case of reversible process, it is assumed that, let me show you the picture again. In case of reversible process, it is assumed that this piston is weightless, and there is no friction between the wall of the cylinder and the piston. That means this piston has two types of virtue or two types of characteristics. Number one, it is a weightless piston, and number two, it is a frictionless piston. But you know that in real world, it is not possible to build any piston which would have no weight. Each and everything that is a living body, solid material, will definitely have some weight or mass. So it is not possible to build up any piston which is weightless or frictionless. It can only be imagined that this piston would be weightless or frictionless. So since the piston is weightless and frictionless in case of reversible process, and in real world there is no such piston which could be frictionless and weightless, so we can say that the reversible process is actually an imaginary process. That is, so the number 2 point is, it is an imaginary process as it assumes the presence of a frictionless and weightless piston. But in case of a reversible process, the piston has a definite weight and it is not frictionless. So it is a real piston. So we can say that the reversible process is real and it can perform actually. Okay. Number 3, since the reversible process occurs in some infinitesimally small steps, so it is possible for maintaining an equilibrium state during the entire operation. But in case of a reversible process, as the operation takes place in single step and it just changes its state or its actual configuration from the initial position to the final position. That is why it is not possible for the irreversible process to maintain an equilibrium state. So what can we say? We can say that in case of reversible process, it is an equilibrium state at all stages of the operation. In case of irreversible process, it is an equilibrium state only at the initial and in the final stage of the operation, but not all stages of operation. Number 4, as the name suggests that the reversible process should be capable of reversed or reversing at any stage of the operation. So the 4th point is, all changes in the reversible process can be reversed when the process is carried out in a reversible direction. But in case of a reversible process, after the accomplishment of one operation, it is not possible to reverse this condition or reverse the attainment, or reverse the end, or reverse the result of this operation. So we can say that after the accomplishment of a reversible process, all changes do not return to the initial state by themselves. Okay. In the definition, we have already stated that reversible process occurs in infinitesimally small steps and it occurs in very slow motion. So our 5th point is, the reversible process is extremely slow, but irreversible process has a measurable speed. That is why we can state that the irreversible process occurs at a measurable speed. And our final difference is that since the reversible process can be carried out repeatedly without losing any energy, so the amount of work that is obtained from a reversible process would be definitely greater than the amount of work that can be attained from irreversible process. So our number 6 point is, work done by a reversible process is always greater than the corresponding irreversible process. And the opposite is true for irreversible process. That is why we are saying that work done by an irreversible process is smaller than the corresponding reversible process. Hope you have understood the concepts of reversible process and irreversible process and the main differences between these two processes. Our next next topics is the internal energy and work done by the internal energy. Before proceeding on our main topics, we have to gain some clear concept about the terms that is going to be used in explaining these topics. That means explaining the topics of our discussion. So let's look at some basic terms and terminologies that will help us to understand our matter of discussion. The number one is work. What is work? According to the physics, you know that work, that means W is equal to Fs. F is the force, S is the distance. So work is the cumulative action that is obtained by applying force, and after applying the force, something will travel a distance. If something travels a distance, then it will be regarded as work. Suppose you have applied a force on a vehicle. Now the vehicle has moved from the initial state to 5 meter apart. That means after applying the force, the vehicle has moved 5 meter. Since there is a combination of force and distance, we can say that there will have been work. Work has been done in the movement of this vehicle. That is why we are saying that work is the energy in the form of orderly motion, which may be, in principle, be harnessed so as to raise a weight. The most common form of work are pressure volume work or PV work and electrical work. The work done by a system against a constant external pressure will be given by W is equal to P external del V. But if the work is done aligned with the system or aligned with the constant external pressure, then the negative sign will be omitted, and the maximum amount of volume expansion that is obtained by work in a system may accomplish under reversible process is given by W is equal to nRT ln Vf by Vi. So what is work, energy, and heat? In these three terms, I have explained what is work. Now let's move on. What is energy and what is heat? Basically, heat and energy are interchanging terms that represents one self. Basically, the amount of energy can be expressed in different aspects and different forms, and heat is one of them in which we can express energy. So heat is a form of energy. What is the role of heat? Heat, whenever any object attains heat, its temperature increases, and whenever any object that loses its heat, its temperature decreases. So heat is a form of energy that will increase or decrease the temperature whenever any object gains or loses this heat energy. But in physics, we define energy as the capacity to accomplish or do a work. So energy is the capacity to accomplish a work, or energy is the capacity to do a work. And I have already told you that energy has different types of form, and heat is one of the form that represents energy. Whenever any object or any form, any material that attains heat, its temperature increases, and whenever it loses its heat, its temperature decreases. And since it is a form of energy, it has the ability to do work. And applying this principle, most of the heat engines give us mechanical work. Most of the heat engine that is available in front of us works on the principle that applies heat as a energy. Okay, now let's recapitulate the main points again. Number one was the heat, work. Work is the combination of force and distance. Whenever you apply force to some object or something, and if this object moves a distance after application of force, then we can say that some work has been done. And the capacity to accomplish a work is known as energy, and heat is a form of energy. Since it is a form of energy, it can accomplish some work, and most of the heat engines accomplish their work by applying heat as an energy to give us some our desired result, that means give us some work. Hope you have understood what is work, energy, and heat. So as we are saying that work is a measure of energy expected by moving an object, usually considered to be the force times distance. Force times distance. No work is done if the object does not move. And the transfer of energy between a chemical reaction system and its surrounding occurs, and work and or heat evolves. So the basic difference between the heat and energy is that energy is the ability of a system to do work, and the change of energy, while heat is the energy being transferred. That means the heat is the energy that is required for changing the state from its one thermodynamic condition to another thermodynamic condition. Now let's move on. Internal energy. What is internal energy? The basic or possible of all kinds of energy that is associated with any particular thermodynamic system is called an internal energy. So as I was saying that internal energy is the total of all possible kinds of energy of a system. The word internal is often omitted, and the energy of a system always implies internal energy. That means if we say energy of a system, it will usually indicates the internal energy of the system. The internal energy of a system, for example, temperature, pressure, volume, etc., is determined by the state of a system and is independent of the path by which it is obtained. Therefore, the internal energy of a system is a state function. For example, if we consider the heating of 1 mole of liquid water from 0 degrees Celsius to 100 degrees Celsius, then there will be a change. The change in internal energy will be 1.8 kilocalorie, and it is the same unless of the form in which this energy is transferred to the water by heating, by performing work, or by electrical means, or in any other way. Since the value of internal energy of a system depends on the mass of the matter contained in a system, it is classified as an extensive property. It is an extensive property. Okay. Now, let's take a look. Already I have told you that internal energy is a fundamental parameter of thermodynamics, and generally the term internal is omitted and the energy is used whenever you are stating that energy of a thermodynamic system. Basically, your statement will ultimately indicate internal energy of a thermodynamic system, and the internal energy of a thermodynamic system is is symbolized with the denotation as capital letter U or del capital letter E. And the definition of internal energy was the total of all possible kinds of energy. That means all kinds of energy indicates both the kinetic energy and the potential energy of a system will be regarded as its internal energy. So considering a system, it will have both the kinetic energy and the external energy. And together, this energy will constitute the internal energy of that system. In thermodynamics, we are concerned only with the energy change when a system changes from one thermodynamic state to another thermodynamic state. So what will be the value of del E? The value of del E will be the difference of the energy when the system changes from initial state, say this is EIN, to the final state, say it is EF. Therefore, we can write that del E is the difference between E final state minus E initial state. Now, if the value of final energy in the final state is greater, then the energy value in the initial state is lower, then the difference will have a positive value. That means del E will have a positive sign. Otherwise, if the internal energy in the initial state is greater than the internal energy at the final state of the thermodynamic system, then the difference will have a negative value and del E will be represented with a negative sign. And I have already stated that whenever energy is transferred to the system or system loses its energy, some work will have to be done, because energy is a form of energy, heat is a form of energy, and in case of thermodynamics, we generally consider the movement of heat from the surrounding to the system or from the system to the surrounding. That is why the name thermodynamics implies. So whenever any system transfers energy, it may either gain the energy or it may either lose the energy, then it will be accompanied by some sort of work. It will be accompanied by some sort of work, and the energy transfer generally occurs in the form of heat. Since work requires energy and energy is a form of heat, so we can say that a system may transfer energy to or from the surrounding as heat or as work, or both as heat and as work. I think you have understood internal energy. Now, what will be the unit of internal energy? The SI unit for internal energy is joule. Another SI unit of internal energy is calorie, and the relationship between joule and calorie is 1 calorie is equal to 4.184 joule. 4.184 joule. Now, why we have to understand about the internal energy? Because the first law of thermodynamics is generally associated with the internal energy and amount of heat transferred to the system. So, for the understanding of first law of thermodynamics, we had to understand the internal energy. I hope you have understood what is internal energy. And the first law of thermodynamics states that the total energy of an isolated system remains constant, though it may change from one form to another. That means In case of an isolated system, the energy do not change. In case of an isolated system, the energy do not change, although the system changes from one form to another form. So since there is no change in the total energy, the first law of thermodynamics is often regarded as law of conservation of energy. Law of conservation of energy. Now let's explain the first law of thermodynamics. Suppose this is a cylinder fitted with a piston, and it contains some quantity of gas or liquid inside it, and the gas or liquid will have some internal energy. And whenever the movement of the piston occurs, there will be some sort of work, because work is the force plus distance. Whenever force is applied to this piston, and if the piston moves from one point to another point, then we will call it a work. During work, there will be a change in the internal energy, and the change may be in the form of heat, as well as work is already done. It may also accompanied by the change in heat. So we can say that when a system is changed from the state A to state B, it undergoes a change in the internal energy. It is already explained in the previous section. So the difference in internal energy will be the final internal energy minus final internal energy minus initial internal energy. This energy change is brought about by the evolution or absorption of heat and or by work being done by the system. Whenever there is a change in internal energy, there will be some sort of work, or there may be a change in temperature. So there will always have work or heat change, or there may be a combination of two kinds of change. That means there will be a work, and also there will be a change in the temperature or heat. Because according to the first law of thermodynamics, the total energy of the system must remain constant. We can write the mathematical expression of the first law of thermodynamics as del E is equal to Q minus W, where del E is the change in the internal energy, Q is the amount of heat supplied to the system, and W, the work done by the system. This is a form of first law of thermodynamics. This is a form of first law of thermodynamics. Okay, I think the first law of thermodynamics is clear to you. Let me summarize the main points again. In case of internal energy, it is the total of all kinds of possible energy in a system. The energy may be the kinetic energy, it may be the static energy, or maybe the combination of both the both the kinetic energy and potential energy. So whenever a system changes from its initial state to the final state, its energy also changes. And in case of thermodynamics, the energy generally indicates the internal energy. So the change from the final state minus the initial state will give you the change in the internal energy. And whenever there is a change in the internal energy, there will have some sort of work, or there will be a change in the heat, or there may be a combination of change in the heat and energy. In this regard, I would like to say that there is a relationship between the heat and work, and we should be able to distinguish between what is heat and what is work. Basically, heat and work are two different ways of transferring energy from one system to another. The distinction between the heat and work is important in the field of thermodynamics. Heat is the transfer of internal energy between the systems, while work is the transfer of mechanical energy between two systems. And in case of the first law of thermodynamics, it states that heat and work both contribute to the total internal energy of a system. So in case of first law of thermodynamics, it is associated with the contribution of both the heat and the internal energy. That means both the heat and work in association with the total internal energy of the system. So the first law of thermodynamics states that whenever an isolated system changes from one thermodynamic state to another thermodynamic state, its internal energy do not changes, remains the same. That is why the first law of thermodynamics is also known as law of conservation of energy. And the, and the mathematical expression of first law of thermodynamics is del E is equal to Q minus W, where Q is the amount of heat supplied to the system and W is the work done by the system. From the mathematical expression of first law of thermodynamics, we can simplify the definition of first law of thermodynamics as the first law of thermodynamics can be stated as the net energy change of a closed system is equal to the heat transferred to the system minus work done by the system. The heat transferred to the system minus work done by the system. So this is all about the first law of thermodynamics. The first law of thermodynamics can be stated in different languages, but the main thing remains the same. You can memorize or you can express the first law of thermodynamics according to your own choice, but you should maintain the main things, and you will find that different book has stated the first law of thermodynamics in different languages. Although the languages are different, but the main points are the same for everyone. So whenever you are attempting to memorize the first law of thermodynamics, you can memorize any definition that you find very easy for you. But you have to write it in the right. You have to write the definition in the actual way, actual order, and you should be able to explain the definition in its original form. Okay. From this illustration, we can see that the piston moves from this initial state to the final state. That means the gas that is confined within the piston expands from its initial state to the final state whenever the movement of the piston takes place. So from this illustration, we can say that as the gas expands against an applied constant pressure P by the volume del V, the total mechanical work done is given by the relationship W is equal to P del V. W is equal to P del V. And from equation 1 and 2, we can see that del E is equal to Q minus P del V. Q minus P del V, where P del V is the value of W. Now the question arises, how W becomes P del V? We know that work is the combination of force per distance. That means force multiplied by distance is known as the work. But in case of thermodynamics, the work has been changed from W is equal to Fs to W is equal to P del V. Now we are going to explain why W is equal to Fs has changed into W is equal to P del V. Let's take a look. In this piston, you can see that there is a gas which is confined in a cylinder, and in this picture, the gas is confined in a cylinder fitted to the piston, and this is the initial position of the piston. To the piston, external force has been applied so that the gas remains compressed, And if the piston moves from its initial state to the final state against an applied external force P, then the volume of the gas also increases as it expands from the compressed state to the expanded state. So, see, this type of work, which is done by the expansion of gas, that means the expansion of volume, is known as pressure volume work. If we can state this as, in the elementary thermodynamics, the only type of work generally considered is the work done in the expansion or compression of the gas. This is known as pressure volume work or PV work or expansion work. Let us consider a gas which is contained in a cylinder, fitted with this is the cylinder, fitted with the frictionless and weightless piston, and the force per unit area of the gas, that means the pressure. Pressure is known as the force per unit area. Pressure is defined as P is equal to F by A. That means pressure is the combination of force and area. So they are saying that the pressure, that means force per unit area of the gas, P exerts a force on the piston. And this external force can be balanced by applying an equal but opposite force from outside on the piston. The gas is applying a force on the piston, and this force of gas is nullified or balanced by applying an external force which is equal to the force of the gas exerted on the piston. So these two forces counterbalances each other, cancels each other. And let us consider that the force which is applied from the external side as P-ext, that means P external. Now, we know that work is the force per unit of force into distance. So work is equal to force into distance. Now, if the piston has moved from its initial position to the final position, it will definitely travel a distance. Let us say the distance is L. Distance is L, and the force required for the movement of the piston from the initial state to the final state was small letter f. So according to the definition, the work will be the force multiplied by the distance. So W is equal to force F into L. But we know that in case of pressure, pressure is the force per unit area. Pressure is defined as the force per unit area. So P is equal to F by area. F is the force, and the area means the area of the piston. So P will be equal to the F by A, and F will be equal to the P external multiplied by A. Now, if we put the value of F in the equation 1, we will get that W is equal to P external multiplied by A multiplied by L. A is the area of the piston. Area of the piston. It will have a area of the piston, and L is the distance traveled by the piston. So we have got three parameters: the length, the breadth, and the depth. And we know that the multiplication of this length, breadth, and depth will give you the value of volume. So we can write V instead of A, because the change in the distance of change in the area, that means the change in the length, breadth, and distance will have two kinds of value, one for the initial state and another for the final state. So we will have a volume in the initial state, and we will have another volume in the final state. So this is the volume of the gas in the initial state, and after moving the piston from this initial state to the final state, the total area and total length and breadth of this cylinder will represent the volume of the gas. So the gas volume changes from the initial state to the final state. That is why the change has been represented as del V. So instead of W is equal to FL, we can write W is equal to P del V. W is equal to P del V. And there is a sign convention, minus and plus. We will talk about that sign convention in our next class. And today, our main topics was the internal energy, the class of thermodynamics, and 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 the explanation why W is equal to P del V. Now I hope you have understood why we have written W is equal to P del V instead of W is equal to Fs. That's all for today's class. Thanks to all for joining.